All right, let's go ahead and go over this. So our H naught is always what? Equals, in this case it's what? What equals? Rho equals what? 0. H1 is? Rho is not equal to 0. That's always going to be it for correlation. Step 2, find your critical value. So I have how many items? 10. My degrees of freedom is going to be 10 minus 2. My alpha is 0.01. So if I go back to this table, 0.01, degrees of freedom 8, 0.765. Negative, and then you should draw a picture.
You got 6, 5? I got 7, 8.
Okay? What? So, it's right here, right? Everybody got that? Mm-hmm. Is that, that's a 6. Oh, maybe you couldn't see it well, but that's a 6. Okay. Step 3, you're going to put this into list 1, you're going to put this into list 2, and you're going to do stat, test, Lin-Reg t-test
So I subtracted wrong.
of L1 and L2. Remember, it's not equal to, right? So that's going to be your test, is the not equal to test. And you should get R, we go all the way down to the bottom, arrow all the way down to the bottom, R equals 0.307. If you did not get that, you should sort that out because it's not hard. This is chapter 10 and 11 are super easy.
I got that.
Okay.
My
Pop that
arrow
in
is
here.
subtraction.
Okay, great. Answer is 0.307. Are we going to reject H naught or not reject H naught?
Do you know?
Yeah. Do not reject H naught. Don't put do not reject. You have to put do not reject H naught. That has to be there. Right? You'll lose a point on every hypothesis test problem if you don't put that. And then last step is not enough evidence because we're in this non-guilty range, right? Not enough evidence to support claim correlation between age and wealth. Good? Okay, great. And they need 15 seconds, 30 seconds? No? All right.
I made a simple mistake. Mine is subtraction.
Okay. So again, the exam, you have how many problems on your exam? 8. So if you do a 2-sample mean independent test instead of a dependent test, you'll lose 7 points. That's almost a whole grade, right? That will drop you from whatever you have to almost a whole grade below on this exam. So it's really important to pay attention and know whether if you do a proportion instead of a mean, that will drop you probably 12 points, right? You know what I'm saying? These are really big problems. So it's really important that you be able to tell the difference between whether you have a mean or proportion kind of problem, and whether you have a hypothesis test or a confidence interval. So we're going to spend the next 20 minutes going over that stuff again to make sure you guys have that down, because if you screw that up, if you do everything else right, if you do the wrong thing correctly, then that doesn't help. If you go somewhere and you paint the wrong house, you're not going to get paid for it. You know what I'm saying? So that could really hurt your grade a lot. All right, so proportion versus mean. Proportion. What does it look like? It has a percent, typically, right? Or it might be a percent in disguise, like 14 out of 92, or out of 389 students, 212 are blank. You're always going to be given an N. In every problem I give you, you're going to have a sample size, you're going to talk about a population. Those are fixed for all of these things, sample and population and an end. What will change is whether or not you have a mean, average, list of numbers, mean in disguise, X bar, or whether you have a, so that's the thing. Means will always, I have to give you the mean, or the average, or the X bar, or the mean in disguise by giving you a list of numbers. Proportions, I won't give that to you. And very often, I'll just give you, here's the percentage. 28.6%. There's your p-hat. I might give you something like this, where I give you the numbers. How do you tell if you have the percentage or the numbers? The easiest way is what?
Percent?
Yeah, the percent sign. Percent will have a percent sign afterwards, right? So that 28.6%, that's not the number of people. That's the percent of people. You guys understand the difference? It has a percent sign afterwards. It's pretty straightforward. Big deal. Because again, remember, your p-hat is going to be your x over your n. I'm always going to give you the n. I'm either going to give you this or that. If it has a percent symbol after it, it's this one. If it doesn't, it's that one. And in your calculator, that better be a whole number, the x, because you cannot have a fraction of a person. So remember, you say I have 28.6% of 212 people, right? So that might be, I don't know, 54.3 people, say. If you go here and you do stat, test, remember proportions are always going to be these props. One prop or two prop, depending whether you have two proportions or one proportion. If I go in here and I put down, I think I got to compare it to 0.236. And I'm going to say, well, that was 54.3 people out of 212 people. It's going to give me a whole big error. Why? Because you cannot have a fraction of a person. So if I do stat test 1 prop z, we're talking about the x's. They need to be whole people. 54. Everybody on board? Okay. Great. So yeah, proportions, again, those are going to be the percentages or the fraction. The mean will literally say mean. The easiest way to tell it's a proportion is it doesn't say mean. It doesn't say average. It doesn't give you a list of numbers. Right? That's the simplest way. And also, don't confuse, it should be a percentage that's not like a 90% confidence interval or a 95% confidence interval, because that's the confidence interval we're talking about, not the proportion. Good. How do you tell if you have a confidence interval or a hypothesis test? Yep. So I'm kind of torn on whether I should emphasize this or not, because those of you paying attention are going to get this right on the exam, and those who aren't paying attention will just fail it on the exam. That's up to you. But yeah, confidence interval will always say confidence interval or estimate. Always. Right? If it doesn't, it's probably a hypothesis test. Hypothesis test may or may not use words like claim, evidence, or test. It may or may not. Or conclude. And those are words it could use, but those are not 100%. Those aren't a guarantee, right? It may not have them and still be a hypothesis test. But if it does have them, then it's a hypothesis test. I should put it that way. So if it has these, it's a hypothesis test. If it doesn't have them, it could be still. The question is, well, does it say confidence interval or estimate? Then it's got to be a confidence interval. All right, don't forget, on the exam, the very front of the exam in bold, I've written, show your work, which specifically means that if you are finding the test stat, I want blank minus blank divided by a square root of blank. Right? I want the numbers in there. so that you've shown me that one, you know the formula, and two, you know which one's the X bar, and you know which one's the mu naught, and you know which one's the S. And then, if you want, then fine, then after that you can totally do stat test, t-test, or whatever it is to figure out, calculate that number, that's fine. But it also will say, for hypotheses test, you have to show all steps, including drawing a picture. For confidence interval, you have to show all your steps. Here are the steps for hypothesis test you need to do. I'm not going to tell you what they are necessarily in the test, but I'm going to tell you them now. Step 1, set your hypotheses, H0, H1. Step 2, find your critical value and draw a picture. No picture, no points for that. Step 3, find your test stat. Step 4, decide whether or not to reject H0. Step 4 is all about H0. H0 should be written there. Step 5, you should not write H0. That's all about your claim. So either you have enough evidence or you don't have enough evidence to support or reject your claim. Okay, and we've gone through that a bunch of times, so I won't belabor you guys with that again. Confidence intervals, you don't need to do that, but you do need to do these other things. You need to figure out what your critical value is. You need to find your margin of error E. And then I may ask you what your best point estimate is. Did we do that last class? Mm-hmm. What's your best point estimate?
Your p-hat.
P-hat or your X-bar. And then calculate the interval. So remember it's going to be, it'll either look like this, like 0.212 comma 0.476, it might look like that, right? Or you could also write it the other notation. So for like a mean, it might say 31.2 is less than mu, which is less than 35.6 or something like that, right? So you can use either format, the interval format or the greater than less than inequality notation. Either one's fine. I don't care. But don't leave it like this. And don't just give me numbers. Don't give me the lower limit and the upper limit. I want them written in, this is how you write a confidence interval. Okay, great. So now you guys know what I expect. We're going to go through a few problems. First one, just warm yourself up. We're going to go through about 10 or 12 of these because they're important. So take 15 seconds with your neighbors, maybe 20 seconds with your neighbors. Figure out whether it's a mean or proportion, T or Z, confidence interval or hypothesis test. The claim is, and where the yellow sheet you are finding it.
It's no, mean with T. So, yeah.
You know how like it has like 4 numbers, right? Or something like
Oh, like 4 different.
yeah, like, yeah. So like, why do we not use it as I don't know.
All right, so this first one, is it a mean or a proportion? How do you know it's a mean? Says average. Says mean too. Great. Is it a Z or a T then? T. Why? Mean Mr. T. Good. Is it a hypothesis test or a confidence interval?
Hypothesis test.
Are you guys sure? How do you know?
It says claim.
Says evidence, talks about claim. Good. And rejecting. Terrific. Also, there is no confidence interval, right? Because the confidence interval will always say confidence interval or estimate. Always. Okay, so what's the claim? I'm going to figure out the claim. Not H1 and not H0 and H1. I'm asking just what's the claim? What are they claiming?
The number of infections going to the hospital is not. Yeah. Because it's
Okay, good. So what is it, guys?
The mu equals the average number of.
Yeah, average number of mu is equals, yeah. The average is 16.3. You guys see these pieces here? Average is 16.3? Yeah.
Would it be less than or greater than?
Yeah, it'd be less, so it'd be, so then the H1, so the claim is H naught.
Yeah.
H1 would be not equal to. It could be less than or greater than. Yeah, either you're equal or you're not equal. So the two times when you're going to have a two-tailed test is when your claim is equals or when your claim is differs, right, or not equals. The two times when you're going to have a one-tailed test is when you have a greater than, right-tailed, or you have a less than left-tailed test.
Wait,
Yeah.
how do you know if it's two-tailed or?
Because your claim is either equal, is, or isn't. When your claim is or isn't, then you're two-tailed. When your claim is greater than or less than, then you're one-tailed. So it all starts with the claim, right? Good questions. Thank you for asking them all. Oh, where in the yellow sheet are you going to look? Yeah, so hypothesis test is going to be on the right, and mean is upper, so upper right. Good. How many samples is this? Yeah, just one, so it's going to be the top row. Remember, the first row is one sample, the second row is two samples. Good. Incidentally, can you write more than this on your yellow sheet? No, no writing on your yellow sheet. All right, if you have, then I will give you a blank one. Because you have a half-page notes. I can't give you the whole world, right? So you have your half-page notes in this. Okay. All right, so 20 seconds with neighbors, we got this one.
No, it's for the mean creativity. And then those two. And then it is. So it's studying
Remember, you're asking these questions: mean or proportion, T or Z, test or confidence interval, what the claim is, and if it's a claim. If it's a confidence interval, there's no claim. And where on the yellow sheet you find it.
The upper left.
All right, so what did you guys find? All right, guys, is it a mean or a proportion?
Mean.
Mean. How do you know?
It says
It says mean. Also, there's an X bar. You guys see that?
an X bar.
It may not say mean, but if it says X bar, that's a mean in disguise. You know, an X bar is your sample mean. X bar, right? Sample mean. Good. Is it a Z or a T?
Oh, yeah, T.
T or Z? T. Why? Mean Mr. T. Means have T's. Great. Is it a test or confidence interval? And here's the confidence interval. Says confidence interval and estimate both. You guys see that? Confidence interval will always say one of those. Always. And hypothesis test will never say either of those. Good. So there's no claim. Where in the yellow sheet are you looking?
Top left.
Yeah, the left side, because it's an estimate, and it's a mean to the top. One sample or two samples? Two. Two, so the second row. Everybody on board with that part? Yes? Okay.
So it's this one.
Are these dependent or independent, guys? It's two means. Are they independent or dependent?
Independent.
Independent. How do you know they're independent?
Oh, there is no.
Because they're what? The samples are different sizes? That's for sure one thing, right? Because they have to be matched up pairs. And because they have to be matched up pairs, what do I have to give you when they're matched up pairs? I have to give you the data. If they're matched up pairs, I have to literally say, here they are, boom, 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 boom. I have to give them to you. You know what I'm saying? So that it has to be two lists of data that are matched up.
So there wouldn't be a problem where it was already
No, you
averaged
can't.
out or,
You can't. I can't.
okay.
If they're dependent, I have to give you them matched up in pairs. So when you see the data matched up in pairs, that's dependent.
So like that.
Not this. This
Not
is not
that.
matched up. Right? They've got to be like 190 and 210, 240 and 245. Right? They've got to be presidents and their opponents. Right?
Okay.
They've got to go together. Do you guys remember that one? Or left arm and right arm. They've got to go together. So this is a two-sample independent. They're just two random samples. Nothing to do with each other. All right. 15 seconds with your neighbors, 20 seconds with your neighbors. All right, so where's your, look at here.
What test and
It can be confidence because there is no
Yeah.
confidence interval. And it's a sample.
the confidence
Anyway, so
say estimate. I think it's a test. Because test might not say.
all right, so guys, what is this? Is it a mean or a proportion? How do you know?
Percentage.
Yeah, there's a percentage. It's not the 95% confidence interval, the 90 or the 80% confidence interval, right? Is it a Z or T? Z. Why?
Easy peasy.
Easy peasy. Great. Is it a hypothesis test or confidence interval? How do you know it's a test?
Because it doesn't say confidence interval.
Because it doesn't say confidence interval, right? No confidence interval or estimate. How else?
The claim.
Yeah, there's a claim. Is there a claim? Oh, there's a claim in disguise, I guess, right? Is the female, is the percentage less than, this is the claim kind of.
Well, also, isn't it a researcher believes?
Yeah, and believes, right. There's all sorts of things in there, right? Most important, the easiest way to tell it apart, honestly, is this guy right here. That's what I would use. If it doesn't say confidence interval or estimate, that's how you know. Because confidence interval will always say confidence interval or estimate, always. All right, so then where on the sheet are you looking? Lower left?
Right.
Right. Lower right? Is it one sample or two samples? One sample. So lower right, the top row. And then see where it says on the very far right where I circled one prop Z test, which you're allowed to circle as well. That's what you can use your calculator for if you want to use your calculator. So all of the tests will have their calculator part with them. The confidence intervals won't because it doesn't really help you. I'm going to make you have to find your E anyways. So, and your critical value anyways, so you might as well just do it the old-fashioned way and use these formulas here. The only thing that's not on here, remember, is the special case, the the dependent, two-sample dependent mean. Okay. Also, does everybody have this here? That first one, no one's crossed anything out here, right? Okay.
I think you
No.
This is the upper second.
The degrees of freedom you do,
DF.
but the very first, the top row, no one's crossed anything out there, right? Okay, good. Just making sure. One class, some people got confused and did something weird. I want to make sure we didn't do that. Okay. So let's try doing this without using your neighbors. 15 seconds without your neighbors because it's more like a real test environment then. Again, these are the things you're looking for. Okay, check with the neighbors.
Don't we
Alright, is it a mean or proportion, guys? How do you know? Yeah, there's a percentage. Percentage, it's not a confidence interval percentage. Is it a Z or T?
Z.
Z. Is it a hypothesis test or confidence interval? How do you know? Says confidence interval. Make sense?
funny.
Great, so then where on the sheet are we looking? Bottom left, how many samples? Just one, so that top part. Oh, I forgot to ask you, what was the claim here? Oh, yes. Yeah, this one's, so the one before. Well, I didn't ask for the claim, I forgot. What's the claim?
Yeah, you did. Believes that.
Oh, yeah, less than. So it would be that what?
H1.
Well, no, I don't care about H1 or H0. Just give me the claim part.
P.
It's proportion, so it's going to be what? P is what? Less than
0.2.
Yeah, 0.23 or 23%. Good? Everybody okay with that part? Oh, you find it. Is so this part right here.
Always gonna be like
Often it'll be at the end or the beginning. Usually it's at the end of the beginning. Yeah, Lincoln?
So for the claim, it's always going to be P, not P hat, right?
Right. Right. Because we know P hat. We don't have to claim anything about it. Do you know what I'm saying? The claim is always about the thing we don't know. Yeah. So it's like I wouldn't claim, you know, that if I looked in your wallet and saw exactly, if I looked in my wallet and said, oh, I have exactly X dollars amount, I wouldn't have to claim how much money I usually have in my wallet because I know exactly how much I have. Right? You claim something about something you don't know. If you know what P hat is, why even claim anything? Was that the same question you had? Okay, good deal. Right, and it's going to be, if it's a mean, this would be what? Mu. Good? Next. Oh yeah, 20 seconds on your own. Talk to your neighbors.
Wait, it's just P hat minus P. Or whatever.
I thought it was and then it'd be
It's one sample.
Is it a mean or proportion, guys?
Proportion.
Proportion, how do you know?
Percent.
Percent? Okay, sounds good. Is it a Z or T?
Z.
Z. And then, is it a hypothesis or confidence interval?
Hypothesis.
Test, how do you know?
So it's claim.
It doesn't say confidence interval. Yeah. All right, so I'll give you guys another 10 seconds to sort out what the claim is. Find the word claims.
Oh, P, yeah. Claims.
70% what?
R.
R. So what's my claim?
P equals 0.17.
P equals 0.17 or 70%, either one. You can do it like that too, that's fine. Good? Great. Do one more and then take a break. So, 20 seconds on your own. Okay, mean or proportion?
Mean.
Mean, how do you know?
It's average.
Mean or average, okay, great. So that's gonna be a T or Z?
T.
Great, is it a hypothesis or confidence interval?
Confidence.
I'm getting two different answers, what is it?
Hypothesis.
Where's the word, find the word confidence interval, you guys see it?
No.
You sure?
Yeah.
Do you see the word average, estimate? So what is it? It's a test. Alright, there's no word confidence interval in there anywhere or estimate. And concluded. Does that make sense? Okay, great. So what is your claim? Okay, concluded at what?
It's not equal
Different.
to U2.
Mu1 is not equal to mu2.
What does different mean?
Not
Yeah,
equal.
so it's what?
Mu1 is
Mu1.
not equal to U2.
Good? Okay, so is this, it's a proportion, so there's no independent or independent. Let's take a 10-minute break and come back at 16 after or 17 after?
Wait, it just said it's a mean.
Oh, it is a mean?
Yeah.
Oh, sorry, so is it independent or dependent?
Independent.
Dependent or independent? What'd you guys say?
Independent.
Why is it independent?
Because they're two separate.
The weight of one baby doesn't, the data is different.
The data is different, they're not matched up.
Yeah.
I have to literally give you the data. Like, here it is. Here, I'll show you what I mean. For it to be
So then
dependent,
it's X,
Right here.
X bar
We
minus
have to find u.
mu
it literally has to look like this, guys.
S over N.
Yeah.
So this is dependent. Do you see where they're all matched up? Like that? I have to give you all of them because you can't, how do you subtract each pair if I don't give you the pairs to subtract? Do you guys understand what I'm saying?
So if there's.
I literally have to give you the pairs like this. If I don't give them to you, then it can't be dependent. If I do give them to you, then it doggone is dependent. You better subtract the pairs and just use that one. Remember, what do? You subtract them, and you do one sample t-test on those differences. That's the dependent thing. It's dependent means you take two samples, you make them into one sample. Good? All right, now let's take a 10-minute break. We'll come back. Good.
How we doing?